Let's look at an interesting problem called number of islands. In this problem, we are given an m cross n 2D binary grid or two-dimensional array in which all the elements are either ones that signifies land or zeros that signifies water. We are asked to calculate the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. We can assume all four edges of the grid are all surrounded by water. Let's understand this problem with the examples here. In the first example, this is the input grid. So if you see all these zeros, they form water, and all these ones they form land. We have to find the number of island, and island is a piece of land that is surrounded by water from all sides. And as the question says, we can assume that this grid is all surrounded by water. So that's the assumption we can make. Another thing to understand is island can include one cell, it can include multiple cells. But these cells have to be neighbor of each other, and neighbor in the way of horizontal or vertical. Let's understand what won't be called as neighbor with the second example. We have to consider ones that are horizontally or vertically neighbors of each other. So that's why there are three islands over here. Intuition to solve this problem. Let's understand how we can approach this problem's solution. If we iterate through this whole grid row wise, whenever we see a 1, we know that it will be part of only one island. All the neighbors of that particular cell and the neighbor's neighbor will also be part of the same island. And here the neighbor are only horizontally or vertically adjacent cells. We have to understand how can we avoid double counting here. This means whenever we iterate through the grid row wise and we see a cell that is 1 in it, we are going to mark all the neighbors and neighbors as visited. If we do that, we know that we are going to eventually mark all the cells in that particular island as visited. If we continue traversing row wise, we see a particular cell that has 1 in it and that was not visited before, we are going to mark it as visited, and we are going to mark all the cells in that particular island as visited. How would we mark all the cells in that particular island as visited? To do this, we can do some sort of traversal. We can do breadth first traversal, we can do depth first traversal, any of it, that should just work. In our solution, we are going to use depth first search. Let's look at the solution. There are two methods. One is mark island as visited, which is solution for the subproblem 2 on how we will be marking all the cells in a particular island as visited. And the second method is num islands, that is the main method that accepts a grid which is a 2D array. First we initialize number of rows as length of grid and number of columns as length of grid's 0th element, which is internal list. So this gives us number of rows and number of columns. This will help us in iterating through the grid. Then we initialize a visited data structure that is again a 2D array of the same size. So initialize island count as 0. As soon as we see a cell that was not visited before and has 1 in it, we are going to increment the island count by 1, and then we are going to mark all the cells within that island as visited. Mark island as visited method accepts grid, visited, I and j. So I and j here are coordinates of a particular cell. We had covered depth first search in one of the videos. You can see that by visiting the link above. To start the depth first search, we initialize a stack using doubly-ended queue in Python. We push the coordinates of cell I, j as a tuple to the stack. Then we start the loop of depth first traversal. We run this loop till stack is empty. In every iteration, we pop from the stack, mark that particular coordinate as visited, iterate through the neighbors, the 4 neighbors of that particular cell. So dr, dc are 0, 1, 0, minus 1, 1, 0 and minus 1, 0. R and C as coordinate of the neighbor. If the coordinates are valid, the grid's value at that particular coordinate is 1 and it's not visited. Again append that particular coordinates to stack as tuple. So this will continue, and by the end of this loop, all the elements in the particular island will be marked as visited. Grid initialized here with a single island. It's the first example that we saw. So it prints 1. We have another grid that has 3 islands in it, so it also returns 3. And then if we initialize a grid that has no island in it, it returns 0. Time complexity and space complexity of the solution. Look at num islands. We are looping through the whole grid And before that, we are also creating visited data structure that has complexity of number of rows multiplied by number of columns. If we take n as the count of all the cells in the grid, which is number of rows multiplied by number of columns, then the time complexity of this particular solution is O of n. In this method, we are again going through a stack data structure. You can get confused by looking at the structure of the code where we are iterating number of rows times, and then internally we are iterating number of columns times, which is number of rows multiplied by number of columns in total. And inside the loop, we are also going through a method mark island as visited, where we are initializing a stack and we are iterating through all the neighbors and then appending them to stack and then popping them again and then marking them as visited, right? We are marking all the neighbors as visited. So you can get confused that it might be more than O of n. But once you visit a particular cell, you're not going to visit it again because you have marked that as visited. Even in the mark island as visited, we do look at the visited value for a particular coordinate before adding it to the stack. So we don't go through a single cell again and again. And that's where it's still O of n, space complexity of the algorithm. We have initialized a visited Boolean 2D array, which is O of n. In mark island as visited, we are initializing a stack, which is a collection, but the number of elements that can go in the stack will be proportional to O of n. In total, the space complexity is O of n. Thanks for watching. See you in the next one.